Students, good morning everyone. Today let me discuss about the disinfection concept. So do you know what is meant by the disinfection? Disinfection, it's a process of killing the harmful disease causing bacteria, or it is nothing but the microorganisms. Killing of the disease causing microorganisms are called as a disinfection. And what is the difference between the sterilization and disinfection? So here the sterilization is nothing but the sterilization is nothing but it's a process of destruction of the all living organisms which is present in a liquid or the water. So it's a complete destruction of the whatever the living matters present in a water. The disinfection is only the killing of the harmful disease causing microorganisms. This is the only difference between the disinfection and the sterilization. And here the disinfection has two components. So what? So here in a primary disinfection and secondary disinfection. In primary disinfection, so its its function is to inactivate the microorganisms in water. And in secondary disinfection, so to maintaining the disinfectant residuals, for example, to maintain the chlorine, that is a disinfectant, it is one of the most effective disinfectant agent in a water. That means to maintaining the disinfectant residual in the distribution system. That is called as the secondary disinfection. So we have discussed disinfection, sterilization and primary disinfection and secondary disinfection. Disinfection is a process of killing the harmful disease causing microorganisms, whereas the sterilization is nothing but the destruction of the complete living matters present in a water. And the disinfection process has two components. One is the primary disinfection and another one is the secondary disinfection. In a primary disinfection, just to inactivation of the microorganisms in a water. That is the primary disinfection. Secondary disinfection process means to maintaining the disinfectant residue in a water. Those are the two components. And then let me discuss about what are the methods of disinfection. One is the boiling of water. These are the different methods to disinfect the water. The boiling of water, treatment with the excess lime, treatment with the ozone, treatment with the iodine and bromine, treatment with UV rays, treatment with potassium permanganate, treatment with the silver process. That means it is called as the electrocatadine process. Treatment with the silver is also called as the electrocatadine process, and the treatment with the chlorine, so that we call it as a chlorination. So these are the methods of disinfection. So whereas in a boiling of water, so simply to boil the water, the microorganisms get destroyed. And the most effective method of the disinfection is a boiling, but it cannot be used for the huge quantities of public water supplies. And so here it also cannot take care of the future contamination of the future possible contamination. That means only by boiling, it removes the microorganisms. That means a disease causing microorganisms. So at that particular time, it is disinfectant. But after that period, that means it cannot take care of the future possible contamination. So that is one of the disadvantage. So at that time, only it is disinfectant. Then after that time, it cannot take care of the future possible contamination. And used only for the domestic purposes during emergencies, that means during pandemic. So the whatever the doctor suggests to drink the boiled water, so that is the only the domestic purposes during emergencies. And it cannot be used for the huge quantities of the public water supplies, because it's the smaller quantity we can boil and drink, but for the huge quantity it cannot be used for the public water supplies. So this is about the boiling of water. And the next treatment method is addition of the lime. That means treatment with excess lime. What happens when we add the lime to the water? So if we add excess lime to water, it kills the bacteria. So here disadvantage is there. When we add lime, so it destroys the microorganisms. But if you add the excess lime, so what happens? The pH of the pH value get increases. That means above, if the pH value is above 7.5, then it is alkaline water, we call it as. So if the pH value of 9.5 or more, it making it extremely alkaline. So thereby killing most of the bacteria. The advantage is by increasing the pH, that means by adding up of the lime, that is the excess lime, it increases the pH, that means the water become alkaline and it kills the effective killing of the bacteria. But the excess lime causes the alkalinity of the water. Then if the alkaline is more, then what happens? So if the alkaline is more, then the water becomes salty taste. And here, so when we when we supposed to choose a lime, that is a treatment with the excess lime, so we have to remove the excess lime present in a water before it is supplied to the publics. That means if you are using if you are treating the water with the lime, then we have to remove the excess lime before it is supplied to the publics. And the next method is the treatment with the ozone. The ozone, that is a O3, we call it as a O3, that is a ozone is a faintly blue gas and of the pungent odor. So we know that. And the O3 can be reaction, it gives rise to O2 plus O, that means the nascent oxygen O. Then ozone, which inactivates the microorganisms. So by what? So by the one method is by direct oxidation. By direct oxidation only it inactivates the microorganisms. And the another is decomposition into hydroxyl radicals, and which are very stronger reactants. So ozone, which inactivates the microorganisms by two methods. That is, one is by direct oxidation only, it reduces R2, it inactivates the microorganisms. And the one more process, one more step is that is a decomposition into hydroxyl radicals, and which are strong reactants. And this method of treatment with the ozone is widely used in Europe and also in USA. So here this method of treatment, that is a ozone, the treatment with ozone, is frequently or widely used in Europe, and also nowadays it is increasing used in USA. And what are the advantages of using this ozone? So here it's a very excellent disinfectant. It proves it has a very excellent disinfectant, and it's able to remove the color, taste, odor from water. So here by other treatment methods, whereas with the boiling of water, whereas with the treatment with the lime, so we cannot remove the color, taste and odor, but this is only the method, that is a treatment with the ozone. So it can be able to remove the color, taste and the odor from the water. And so whatever the ozone treated water becomes tasty. So here the ozone treated water becomes very tasty, and it's able to remove the color. If it is having a more color or taste or the odor, it's only the treatment method, it removes the color, taste and odor. So that's why it's effectively used in USA and Europe. And the water also become tastier one. And the disadvantages are, it's more costly than the chlorine. So whatever we are using the chlorine method, so that is a common method of using the disinfectant. So compared to that chlorine method or the chlorination, it's more costlier, and it does not create disinfectant residual. So it does not create any disinfectant. So what we are talking about, that is the residual which is left in the water, so that is not there in a ozone type of the treatment. That means does not create the disinfectant residual, and it is potentially explosive, yes, and it may produce the harmful byproducts. So when we use the ozone as a disinfectant, it produces the harmful byproducts because it's a ozone and it is highly potentially explosive one. but it is more effective type of the disinfectant, and it can able to remove color, taste and odor from the water. And the treatment with the iodine and bromine. So here, when we treat the water with the iodine and bromine, these disinfectants are nowadays are available in the form of pills. Yes, nowadays it is available in the form of pills, that is a small tablets like, and it is more costlier than the chlorine. So that's why we called the chlorination is one of the effective and the common disinfectant we are used. So here the iodine and the bromine pills are also costlier than the chlorine. Then the iodine gives a longer lasting protection, because so here when we add the iodine pills, it gives a protection, that is a future protection, also it gives about the against the pathogens. Iodine gives the longer lasting protection against the pathogens, and it is used for water supply for army troops, private plants, swimming pools, etc. So it is also, it cannot be used for the supply of the public supplies or the larger quantity of the supplies. It can be used for the army troops, and it is very suitable for army troops, private plants and the swimming pools. Treatment with the iodine and bromine, and these tablets and these pills are costlier than the chlorine. And it gives the major advantage of this using of the iodine and the bromine is, so it gives a longer lasting protection against the pathogens. If the pathogens presence is more, then we can go for the iodine and the bromine method of treatment. Then the next method of the treatment is the treatment with potassium permanganate. The treatment with potassium permanganate. So let me discuss about, okay, then the next method is treatment with UV rays. First we'll discuss about the treatment with the UV rays. So when we pass the UV rays, so it's an invisible light rays having the wavelengths of 1000 to 4000 microns. So it's a ultraviolet rays that we are used, and these are invisible light rays having the wavelengths of 1000 to 4000 microns. And these rays are highly effective in killing all types of bacteria. So it is very effectively killing all types of bacteria, and the water to be treated with the UV rays should be less turbid and low in color. So here, so whatever the water treated with the UV rays should be less turbid and it should have a low color. If the highly turbid water, we cannot be treated with the help of the ultraviolet rays, that is a UV rays type of the treatment. So if the water which consists of the less turbidity and the low color, so then we can use the treatment with the UV rays. This is one of the disadvantage of the treatment with the UV rays, and it is very costly and it needs the technical support. Yes, because we are using the UV rays, that means it's an invisible light rays having the wavelength of 1000 to 4000 microns. So that's why it needs the technical support. The major disadvantage, so the water should be less turbid and it should be in a low in color, and it is unsuitable for treating the large scale water supplies, that is for the public supplies. Yes, it is unsuitable because to pass the UV rays it is costlier than the other types of the treatment methods. So it is unsuitable for treating the large scale public supplies, and adopted for water supplies for the private buildings, institutions, swimming pools, etc. So it is having, so we can use it for a private buildings, institutions and the swimming pools, etc. And the next method is, that is treatment with the silver. So here, before going to the treatment with the silver, let me discuss about the treatment with the potassium permanganate. So here, these are the different treatment methods what we are discussing today. The methods of disinfection, these are different methods. The one is by boiling of water and the treatment with the excess lime, treatment with the ozone, treatment with iodine and bromine, treatment with the UV rays, treatment with the potassium permanganate, treatment with the silver, and the treatment with the chlorine. These are the different methods of disinfection. So let me discuss about the treatment with the potassium permanganate. So this is a popular disinfectant used for the disinfection of the sources contaminated with lesser amount of bacteria. So when we supposed to use the treatment with the potassium permanganate method, because when the lesser amount of bacteria are present in a water, then in that for that water we can go for the potassium permanganate process. So here this is one of the disadvantage. So here the water should consist of the lesser amounts of bacteria. So then only we can go for the potassium permanganate treatment. And the normal doses of disinfectant is 1 to 2 mg per liter with 6 hours contact time, and it cannot guarantee the 100% removal of the bacteria. So here, so by comparison with the other treatment methods or the other disinfection methods, so potassium permanganate, it is cannot guarantee, it does not give guarantee for the 100% removal of the bacteria, and it cannot give the 100% removal of the bacteria. That is only the disadvantage of the potassium permanganate, and it is rarely used. And treatment with the silver. So if we talking about the treatment with the silver, that process is technically called as electrocatadine process. So that is technically called as it's a electrocatadine process. That means in this method, the disinfection, in this method of disinfection, the metallic silver ions are introduced. So introduced into the water by passing it through the tube containing the solid silver electrodes, which are connected to the DC supply of about 1.5 volts. So it is passed through what? That is a tube containing the solid silver electrodes, and which is connected to the DC supply of about 1.5 volts. And the recommended silver dose may be vary between 0.05 to 0.1 mg per liter with a contact period between 15 minutes to 3 hours. Within 3 hours, we can disinfect the water by using the silver. And the silver treatment neither imparts any taste and odor to the water, nor it produces the harmful effect on human body. The use of silver is costly, so hence not adopted for the public water supplies. So we know that this treatment method is very costlier. This treatment method is costlier, and it cannot be used for the public supplies. And the use of silver, and this disinfectant removes the algae, so it's one of the major advantage. So when we go for the electrocatadine process, so it's able to remove the algae and takes care of the future contamination. So here this disinfection method, we can able to remove the algae and take care of the future contamination, but it is very costlier than the other treatment methods. And let me discuss about the last treatment method. It's the most commonly and most universally accepted disinfectant method is the treatment with the chlorine. So here the chlorine is almost universally used for the drinking, for the disinfecting public water supplies. It is cheap, reliable, and easy to handle, and capable of providing the residual disinfecting effects for long periods. And thus it is affording complete protection against the future contamination of water in the distribution system. So what are the last method, that is a treatment with the chlorine, or we call it as a chlorination. It's a universally accepted disinfection because it's very cheaper, reliable, and easy to handle, and capable of providing the residue disinfectant effects for a long period. That is a long lasting protection against the pathogens. And its only disadvantage is that it imparts bitter and bad taste when we used it in a excess amount. So the only disadvantage is when we use it in excess amount, so then it causes a bitter taste. And then what is the disinfection action of the chlorine? So chlorine, that is Cl2, when it is added to water, that is H2O, it forms the hypochlorous acid and hypochlorite ions, which have immediate effect on the microorganisms. So which have the immediate effect on the microorganisms. Cl2, when it is addition with the water, so it gives the hypochlorous acid or the hypochlorite ions. Cl2 plus H2O gives rise to HOCl. HOCl is the hypochlorous acid plus HCl. So then HOCl, that means a hypochlorous acid, when it reacts, gives rise to the hydrogen ion plus OCl minus. OCl minus ions are hypochlorite ions. So one is the hypochlorous acid, then the another one is the hypochlorite ions. So OCl minus ions are hypochlorite ions, HOCl ions are hypochlorous acid. And here, so here one reaction, that means it will depends upon the pH of the water. So if the pH of the water is 5.5, that means a lesser, whereas the water which is in an acidic condition, so that means the pH, if it is 5.5 and it's 100% HOCl and no OCl minus, that means if the water is in acidic condition, so when the reaction takes place, there is a production of the 100% HOCl, that means a hypochlorous ion, hypochlorous acids. If the pH is greater than 9.5, that means if the water which is in alkaline condition and which gives this reaction gives rise to the 100% OCl minus ions and no HOCl. So here this the disinfection action which takes place on the pH. The pH is a matter here. So here based on pH, that means if the pH is 5.5, that means it is an acidic water. It completely 100% of the hypochlorous acids are produced. If the pH is greater than 9.5, 100% OCl minus ions are produced. If the pH is in neutral, that means is equal to 7.5, the 50% of the HOCl, that means a hypochlorous acid, and 50% of OCl minus ions, that means a hypochlorite ions, are produced. This is the reaction which takes place in a chlorination. And hypochlorous acid and hypochlorite ions accomplish the disinfection of water. So here this will accomplish the what? Disinfection of water. The sum of the hypochlorous acid, hypochlorite ions and molecular chlorine in a sample of water is termed as a free available chlorine. So what we call it as a free available chlorine? So whatever the hypochlorite ions are present and hypochlorous acids are present in a water, so that we call it as the free available chlorine. And the free chlorine, when it reacts with the compounds such as ammonia, protein, amino acids and phenols that may generally be present in water to form what? What it forms when the free chlorine, that means the hypochlorous acid or hypochlorite ions, when they reacts with the compounds which are present in a water, that is the ammonia, protein, amino acids and phenols, so that will give rise to the chloramines. That means the chloramines, it's also a monochloramines, dichloramine, trichloramines. So when the hypochlorous acids, HOCl ions, hypochlorous acid HOCl, when it reacts with the ammonia, so gives rise to the monochloramine. So when it is reacts with the protein amino acids, it gives rise to the dichloramine. When the hypochlorous acids reacts with the phenol, it gives rise to the nitrogen trichloramine. The chloramines so formed are stable and are found to possess the disinfectant properties. This is the theory which is behind in the what? That is the chlorination or the chlorination action. This is called as the chlorination action. That means the chlorination action is when the chlorine reacts with water, it produces the hypochlorous acid and hypochlorite ions. When those hypochlorous acid reacts with the ammonia, protein ammonia and phenols, it gives rise to monochloramines, dichloramines, nitrogen trichloramines, and these formed are stable and are found to be possess disinfectant properties. And what are the factors affecting the bacterial efficiency of the chlorine? What factors it will affect? So the factors affecting the bacterial efficiency of the chlorine. What the factors will affect? So here The factors affecting the bacterial efficiency are the turbidity. So if the turbidity is more, then the efficiency of the disinfectant is also less. So here this will affect, turbidity affects the effectiveness of the disinfection. That means if the turbidity is more, the effectiveness will be less, the efficiency will be less. And if the metallic compounds are present, that means the iron and manganese present in a water, that will also reduces the effectiveness of the chlorine. And the ammonia compounds, if the more number of the ammonia compounds are present, that will also reduces the efficiency of the disinfection. If the pH is increased, that will also reduces the effectiveness of the chlorine. If the temperature, at lower temperature, will reduces the efficiency of the chlorine. And the killing of bacteria increases with the increase in the contact time. That is, if the contact time increases, the efficiency will be more, and if the contact time is less, then the efficiency will be less. So these are the factors affecting the bacteriological efficiency of the chlorine. And what is the dosage of chlorine? So normal dosage we are using 0.3 to 1.1 mg per liter, and the residual chlorine is 0.1 to 0.2 mg per liter. So these are the factors affecting the bactericidal efficiency of the chlorine. So let me discuss about, so methods of disinfection is over. Then what are the factors affecting the efficiency of the chlorine? Turbidity, metallic compounds, ammonia compounds, pH, temperature, contact time. And the dosage of the chlorine is normal dosage 0.3 to 1.1 mg per liter, and the residual chlorine is 0.1 to 0.2 mg per liter. And what are the forms of the chlorine? So here the chlorine can be applied in the form of, as a free chlorine, we can use the liquid chlorine or chlorine gas. And as a combined chlorine, we can use as hypochlorites or bleaching powder, chloramines, chlorine dioxide, chlorine tablets. So these are the forms of the application of the chlorine for the process of chlorination. So one is either we can go for the chlorine gas or the liquid chlorine, or in a combined chlorines like when we add a bleaching powder in the form of the bleaching powder, or in the form of the chloramines, or in the form of the chlorine dioxide, or in the form of the chlorine tablets. So these are the forms of the chlorine. And let me discuss about what are the types of chlorination. So here we are talking about the most common, the effective method of the disinfection is the chlorination. So then what are the types of chlorination? So here the types of chlorination are plain chlorination, pre-chlorination, post-chlorination, breakpoint chlorination, superchlorination, double chlorination, and dechlorination. So these are the process. These are the types of chlorination. Then what is meant by the plain chlorination? So then what is meant by the plain chlorination? What it means? So when we simply, so when we add the chlorine to the water, it helps in removing the bacteria. That means the raw water is given chlorine treatment. When we add some chlorine to the water, so that we call it as a plain chlorination. So just by adding the chlorine to the water for the removal of the bacteria, the organic matter, and the color from the raw water. So during emergencies, so just we add the chlorine to the water. So that is called as what? That is a plain chlorination. And the dosage of chlorine is about 0.5 mg per liter or more. Also we can use. And what is meant with the pre-chlorination? So here, before the sedimentation or coagulation, when we add the chlorine, when we apply the chlorine, so it's a what? It's a process of applying the chlorine to the water before filtration, or rather before sedimentation. So we are applying the chlorine to water before the sedimentation or before the filtration. We call it as a pre-chlorination. So that is the process of the pre-chlorination. It helps in improving so when we add the chlorine before the filtration and before the sedimentation, that helps in the coagulation process. So if you add chlorine before the sedimentation or coagulation, it improves the coagulation. And if you add the chlorine to water before filtration, it improves the filtration process. Then what is meant by the post chlorination? So it is the standard form of chlorination in which chlorine is added to water as it leaves filter and before it enters a distillation system or distribution system. When we add the post chlorination is after the filtration process, when the chlorine is added to the water, that process is called as the post chlorination. Pre is nothing but before the filtration, before the sedimentation or before the coagulation, when we add the chlorine is called as pre-chlorination, and the post chlorination is after filtration, before it's going to the distribution system. When we add the chlorine, that process is called as post chlorination. And what is meant by the breakpoint chlorination? So what is meant by the breakpoint chlorination? So here it's a point beyond which any further addition of the chlorine will appear. So that will equally as a free chlorine. So the point C is called the break point. That means at beyond that point which any further addition of the chlorine will appear is called as the breakpoint chlorination, at which beyond which further addition of chlorine will appear equally as fluorine. That means at that particular time there is no consumption of the chlorine for the process. So whatever the chlorine content we are adding, that should be just take it as a free chlorine. So that point, at that point we call it as a breakpoint chlorination. Beyond that point which any further addition of the chlorine will appear, and if it is appear, it's equally as a free chlorine, since nothing of it shall be utilized. That point we call it as a breakpoint chlorination. Then what is meant by the superchlorination? If the water is completely polluted, if the water is completely polluted, so then we can go for the superchlorination. So here the dosage of adding the chlorine is about 0.3 to 1.1 mg per liter. But whereas in a superchlorination, the amount of chlorine addition is 5 to 15 mg per liter of water. 5 to 15 mg per liter. So when we add the chlorine of 5 to 15 mg per liter, so when the water is highly polluted one, so that we call it as what? That is a superchlorination. And here it may used when there is a reason to believe that water contains cyst of histolytica. So when the water which consists of the cyst of histolytica, that means the organisms which cause amoebic dysentery. So in that particular type of the water, we can go for we are supposed to use the superchlorination. The superchlorination, when the water is highly polluted, that means it consists of the amoebic dysentery causing microorganisms, that is the cyst of histolytica is present. So then we go for the superchlorination. So the dosage is 5 to 15 mg per liter. And the dosage is 5 to 15 mg per liter. Then what is meant by the double chlorination? Double chlorination, it's a process which is chlorinated twice. That means the pre-chlorination and the post-chlorination are generally used in double chlorination. And it is adopted when the raw water is highly contaminated and it contains large amounts of bacterial life. So in that condition, we go for the double chlorination before the treatment process. That means before filtration, sedimentation or coagulation, we are adding the chlorine, and after filtration also we are adding the chlorine. So 2 times. That means the chlorination, the process of water is chlorinated twice. So that is called as a double chlorination. And what is meant by the dechlorination? So what is meant by the dechlorination? So dechlorination is nothing but the removal of the chlorine. The dechlorination is nothing but the removal of the chlorine from the water. The process of the removal of the chlorine from the water is called as the dechlorination. So here these are the what? These are the types of chlorination. So here these are the types of chlorination. So let me brief about dechlorination. Means that is removing the chlorine from water. So that's the process is called as the dechlorination. And what are the common dechlorinating agents? So to remove the chlorination from the water, chlorine from the water, some agents we are using. for the removal of the chlorine. So that we call it as a dechlorinating agents. What are those? So here the dechlorinating agents are activated chlorine, the activated carbon, and the sodium thiosulfate are the common dechlorinating agents. So we have discussed about the methods of disinfection, types of disinfection, the forms of the chlorine we used, and the dosage of the chlorine, and what are the factors affecting the chlorination, and the last is the testing of the chlorine residues. So how we are going to test the chlorine residues? So one is the method, that is the orthotolidine test. The orthotolidine test. So here there is the most commonly used test to determine the residual chlorine in a water. So here how we are going to test the chlorine residues? Orthotolidine test, starch iodine test, DPD test, chlorotex test. So most commonly we are use the orthotolidine test. So let we discuss about the orthotolidine test, how we are going to determine the residual chlorine. So in this test, 0.1 ml of orthotolidine solution is added to what? To 100 ml of the chlorinated sample. So here it's a testing method for the chlorine residues. So whatever the residue which is left in a water, that can be tested by using these methods. One is the orthotolidine test, starch iodine test, DPD test, and chlorotex test. So these are the testing process. And in this method, orthotolidine test, for 1 ml, 0.1 ml of orthotolidine solution is taken and which is added to the 10 ml of the chlorinated sample. The yellow color produced is noted and compared with the colored glass standards, and thereby residual chlorine is ascertained. So if yellow color is produced and it is compared with the color glass standards, and thereby residual chlorine is ascertained, that is noted. The color produced after 5 seconds of time represents the free residual chlorine, and that produced after 5 minutes represents the total residual chlorine. So here if the yellow color is produced, then that gives a what? So it is ascertained, that means the standards, and if yellow color is produced, that can be compared with the standard glass standards, and the color produced after 5 seconds of the time, so that represents the free, yes, it's a presence of the free chlorine, and that produced after 5 minutes represents the total residual chlorine. So if again the color which is retained yellow color after 5 minutes also, then we can call it as total residual chlorine is present. So this is how to test the presence of the residual chlorine. So other methods are the same. So here in orthotolidine test we are use the orthotolidine solution, whereas the starch iodine test we are using the potassium iodide solution. So like that, these are the testing process of the determination of the chlorine residue. Thank you, students. I think you have understood in a better way the concept of the disinfection, sterilization, methods of the disinfection, types of chlorination, and the theory behind the chlorination, and what are the forms of the chlorination, and what are the tests to find out the chlorine residues. Thank you one and all.